When we were coming up with the presentation, we were struggling with who is our audience, and we had widely different opinions about the familiarity of people with CloudStack. So I'd like to know who's used CloudStack before. Okay, that's about roughly 30–40%. Who's developed on CloudStack before? Wow. Okay. And who's familiar with other cloud platforms like Eucalyptus or OpenStack? Okay. So, and then who's used things like Amazon Cloud? Deployed? Oh wow, that's excellent. Thanks. So as I said, the presentation may not be, fitting your needs, and so please tell us if you need more explanations or if you want me to go in a different direction. I know that it's being taped and he has my presentation, but I'm sure we can go off course. This is the clicker. I'm going to go over like what is CloudStack, what kind of problems does it try to solve. I'll go over some of the features which, given that about 30% of you have actually used CloudStack, it might be new to you. I'll talk about the system architecture and give you some kind of context about what are the various parts of the system architecture, and then Alex will take over and go a little more in depth about the actual architecture of the product. Any questions so far? So what is CloudStack? So when we developed CloudStack, like we started in the end of 2008, and it was always a decision or a view that if something like Amazon can be so successful, why not other providers, why not other enterprises, why can't they be so successful in deploying and building clouds? And so we set out to build a turnkey platform for delivering IaaS clouds. And then somebody like Amazon has the luxury of sticking to a single hypervisor, but typically you guys are interested in deploying on different hypervisors. So being hypervisor agnostic was one of our goals. Scale, of course, just like what Amazon, Rackspace, etc. do. Secure, because if you're deploying on a public cloud, if you're not secure, nobody's going to deploy on you. And although initially CloudStack was not open, I think in the middle of 2010 we open sourced most of it, and then when Citrix acquired Cloud.com, we open sourced everything. So it was all GPL. We developed in the open, and as you guys know that in the beginning of April, we donated the code base to Apache, and we're incubating in Apache. And then some of our customers also host CloudStack for other people. And so that's another use case which CloudStack solves. And then, of course, cheaper and faster is always the goal for any product. So some of the places where CloudStack is deployed, we have on-premise dedicated clouds where it's behind the firewall and it's total control of the enterprise. So the security and total control of from the enterprise perspective. We also have hosted enterprise clouds where there's the service provider installs physical resources for the customer and then manages the cloud for the customer. And we have multi-tenant public clouds, which is our by far the greatest success CloudStack has had, just because that's the emerging market, or the market that has emerged first, is an Amazon-style public cloud, where there's multiple tenants isolated by various technologies, and they can get elastic resources from the cloud. Any questions so far? One of the nice things about CloudStack is that we have a fantastic UI, and I'm not sure if our UI designers are here today, but we paid a great deal of attention to the look and feel of the UI to make it a very usable UI, and that's not just for the end user, but also for the admin. And so both the end user UI and the admin UI are backed by, or they use the end user API or the admin API to interact with CloudStack. And then we also have a bunch of third-party clients like Fog or Knife, or we have a built-in Python client which you can use to interact with CloudStack. Wrong button, sorry. So as what an IaaS cloud does is that it orchestrates physical resources in order to provide virtual computing resources to you. And the physical resources include compute like hypervisors, Xen Server, VMware, Oracle VM, KVM, and bare metal is what is supported today. And storage. And so you can run your VMs on local disk, on SAN or NFS, or you can even store template images on something like Swift and then boot from there. And we also control networks, and that's by far like the biggest flexibility which comes with CloudStack, is that you can control many different kinds of network devices and provide services from layer 2 to layer 7 to the end user. Any questions so far? So as I said, the problem definition was a scalable, flexible, manageable IaaS platform, and the following established cloud computing paradigms was important because we had a good example, which was Amazon, and so an Amazon-style cloud is what CloudStack tries to emulate. What IaaS does, of course, is it orchestrates physical and virtual resources to offer self-service infrastructure and provisioning and monitoring at large scale. And something which Citrix talks about is when you traditional virtualization, you have one admin trying to manage 10 servers or 20 servers. When you move to something like an IaaS cloud, you have one admin handling thousands of hosts. So it's the difference in scale, a difference in price points, and difference in ease of use, in automation. And the scalability we're talking about is, when people download CloudStack and use it, they have just typically one host or two hosts to play with. And so the intention is that it should be easy enough for them to run a two-host cloud. And I remember when we started and we were looking at other IaaS platforms, and we would wonder why people would download, let's say, something like, I think there was Eucalyptus and a couple of others at that time, and run a cloud on two hosts. I mean, it just didn't make any sense to me. Now it does, because I know a lot of you guys just want to try it out first. And so it's important that it works from either one hypervisor or tens of thousands of hypervisors. And it's the same ease of use. It's no extra, there's a few configuration tweaks to make, but it should be just the same experience. And likewise, if you're an end user and you're using a public cloud, you want your public cloud to support thousands and thousands of users. And because it's it's software designed to be flexible, so we want to be able to handle new resources. I think over the years we've added support for Oracle. I mean, we started with Zen Server, open source Zen. Then we added support for commercial Zen or Zen Server, and then we added support for VMware, KVM, and Oracle VM. So at the same time, there's not been any much change to the kernel. The kernel of CloudStack doesn't really care about what's underneath because there's just drivers to be added there. And as we have added more network APIs, more storage APIs, we've gone beyond the original Amazon set of APIs. We've been able to add those APIs very easily. And then as end users or admins of clouds, you guys want additional services. And so we've been able to add those easily as well. And a very important goal for CloudStack is to be manageable. And so when you're using the Amazon cloud or Rackspace cloud, you really don't know what's underneath, what hypervisor is there, are you using a Intel CPU or AMD CPU, right? So hiding that complexity of the underlying resources is a goal, and so the UI fills a large part of that usability goal. And then an admin API, which other clients can use to drive automation in the cloud, is also a very important goal and a big part of CloudStack. And so you'll never find the UI talking to CloudStack through a secret channel. It's always through the admin API. The easy install upgrade, of course. Simple scaling. So it should be as easy as adding more memory or adding more CPU cores to scale this to scale CloudStack. And automated resilience is that if the underlying physical resource is not behaving the way you want it to behave, well, what does CloudStack do, right? And then resilience is one goal of CloudStack. And as I was saying before, EC2 inspired. It is a large part of our API set and a large part of the semantics of CloudStack is driven by what Amazon established. But at the same time, we have had experience with 100 different customers who asked their own changes, and also the open source community, of course. And so there are semantic variations, and there are some things which you just cannot do if you don't own the infrastructure. So there will be semantic variations. Any questions so far before I just go through the more general overview of CloudStack and how it works? Hybrid clouds, anybody? Sorry. Sure.
All over hybrid.
Yeah.
So do you have many customers already using this in a hybrid scenario? And are the APIs, the management APIs, exposed to the downstream end user customers so that they can manage deployments in both on-premise and off-premise cloud?
Are you talking about the admin API specifically?
Yeah.
No, I'm not familiar with that. But yeah, sure.
Disney. So we're using Rackspace, Internet.
Can you give him the mic, please? Oh, he has one right there. Sorry.
Yes, so Disney right now has our production.
Yeah, it's not on, I think.
Hello? Hey, guys. So Disney has actually done some work in this area using Chef and Knife, and also some custom gems we wrote for Puppet against Internet, Rackspace, and then AWS and Amazon. And then we're just using if-else statements or a specific gem call in order to automate the implementation, but it's all physical hardware. So we're not actually building VMs out in the public clouds. What we're doing is we're building physical servers, extending our hypervisors, adding into our management server, and then managing it as a bursted environment. And then when we're done, we wipe the drives, and then we collapse it out of the public cloud. So right now, we're not putting anything out there. We found a number of things that are preventing us from bursting in a hybrid cloud, particularly load balancers, GTM across multiple spaces without DNS round robin. Makes it very difficult to burst on demand. It takes a lot of effort to get it done. Additionally, firewalls, managing IP tables out in the public cloud versus managing traditional ACLs on a firewall. Trying to work with vendors like Cisco, Nicira, and a couple others to get a common API that firewalls are now consistent across the environment itself. And a couple other nuances, but we're still working it out, and I think we've talked to Shang and a number of his team, and even vendors themselves to kind of push them in this direction of meeting the traditional private infrastructure along with a public cloud burst-based scenario.
That sounds very exciting, thanks. Could you introduce yourself? Sorry.
I think I turned this thing up. Pete Lopez, architect at the Walt Disney Company.
And Pete just mentioned Sheng. I don't know if you guys have met Sheng. Sheng was mover and shaker behind Cloud.com, and he's here today too. So, any other questions? So Pete, just to follow up on that, what was the key to bursting? Is it just the fact that the APIs are so usable, or?
Well, we actually started everything on the EC2 APIs, but we found that it's not completely covered in the EC2 implementation in CloudStack. So what we did is we actually threw a variable for determining which place we're going. The preference would be to use EC2 as a common API base, and then to expand out in a way that's consistent, so we wouldn't care which cloud it's at. As long as you're using EC2 calls, you can either do private cloud or public cloud. But the real work actually came into the actual API calls themselves and to make it actually a consistent interface.
Great, thanks. So what I'm going to go through next is could be a little bit old hat for those of you who have already used CloudStack. So bear with me. So if you're an end user, and if you use an Amazon cloud, this should be fairly familiar to you. There's a launch wizard, which if you want to deploy a VM. You pick a service offering. So you first pick a template, what Amazon or anybody else calls an image, we call a template. You can pick the operating system. You pick a service offering, small, large, medium, and one small. These offerings can be customized by the admin, through the admin API, of course. And then a lot of CloudStack users like to offer fixed size of volume disks. So you can also customize this as the admin, whether you want to offer small disks or large disks. I believe you can also offer an unlimited disk as well. And then you can choose which network you want to deploy on, and or you can add a new network. So each tenant can own multiple networks, somewhat like an Amazon VPC, and deploy the VM on that network or on multiple networks. So for example, if you checked customer net and VLAN 100, then your VM would have two NICs, one on customer net and one on VLAN 100. And then boom, you create the VM, and then you get this nice little dashboard which shows you what's running and what's stopped, etc. And then just all your virtual resources, which are instances, storage, network, any templates that are visible to you, and those that you have uploaded, events. For example, you just created an event, and then we have a feature called projects, which you can use to collaborate with different users. So if you're a user, you can do regular VM operations: start, stop, restart, destroy. Fairly standard for an IaaS cloud. You get an console access through a Ajax console, which is, you don't need to install anything. It displays right on the browser. You get statistics about the VM, how much CPU is utilized, networks, read and writes. No disk I/O yet. And then you can always shut down your VM, change the service offering. I'm on 2 CPUs now, I want 4 CPUs, and boom, you're up and going. As an end user, you can manage volumes, add whatever volumes you want to your VM. You can add a new volume, detach volumes, and move them around, just like Amazon. Create a template from the volume. So let's say you started with, what you can do is you can start with an ISO. You can boot from an ISO in CloudStack, and then you provision your, you install the VM into a volume. Install all the, let's say you're creating a MySQL template. You boot from, let's say, the Red Hat CD. You install Red Hat on a volume. You install MySQL on it. Customize it the way you want. You're happy with it. And now you can create a template from that volume. And then the next time you can just use that template to create a MySQL server. You can snapshot. There's a snapshot API and a snapshot on demand, or you can create a schedule, hourly, daily, weekly, monthly. And then you can see, well, what snapshots you have, and then delete them selectively. As far as networks goes, you can create networks. As I said, you can create any number of networks and attach VMs to multiple of them, so multiple NICs is supported. Typically, you're working in if you're working in a public cloud, you have your private addresses for the VM themselves, and then you have public addresses. And then we allow you to acquire multiple public IP addresses, and then use port forwarding, NAT, firewall, in order to provide services to the rest of the internet from your VM. And then if you're using like the Amazon style security, you can do ingress and egress firewall rules, security groups. And then you can start up load balancers to load balance between VMs. And this is all orchestrated by CloudStack, of course. What you see here is the list of IPs you have. All these are in the San Jose zone. Actually, this is an admin view, isn't it? Yeah, it's an admin view. Obviously, the admin is seeing everybody's VMs or IP addresses there. Let me just pause here and ask about any questions about features. This is 3.0, yeah. Are people still using 2.2? A lot of them? Okay. Just like AWS, Amazon Web Services, we support multiple availability zones. Not sure why that clicked so fast. Okay. And then within a zone, we assume the following physical resources. You have your hosts, which are hypervisors, and the hosts are managed as clusters because that's what the underlying hypervisor manager expects. For example, a VMware or a vSphere cluster, a Zen server cluster, or even if it's KVM, we just automatically cluster them. And then all these hosts share primary storage so that you can migrate between hosts. So if you use the admin API, you can put let's say, host 1 into maintenance, and then the VMs that are on host 1 get live migrated to host 2 automatically. And then all these clusters are organized inside a pod. And typically there's like an access layer or like at the top of the rack switch, which connects to the L3 core of the data center. And then you just repeat that pods so that you get this uniform view of the data center. And then the management server, is managing it through the outside. You can manage it from outside the firewall. It doesn't have to be inside the data center. And then you get access to the internet through the L3 core. You also see secondary storage there, and so that's just typically an NFS server, fairly easy to get up and running. And that stores your images, templates, snapshots, and ISOs. And that secondary storage can be something like Swift, or maybe in the future something with an S3 API. Oh, question.
Just had a question on the live migrate. My name is Jayesh. So are you using a native technology for live migrate, or is there a generic technology that's there for live migrate?
Yeah, I think that's a great question. So when CloudStack talks to the hypervisor, it always talks native APIs. There's no, if it's VMware, we use the vCenter API. If it's Zenso, we use Zappy. And if it's KVM, we use the libvirt as the native API. So it's always the native API. We don't try to second guess the hypervisor manager.
Hello?
Yeah.
Hi, I have a question. In this diagram, there's 4 tiers. I'm interested in the cluster tier. What is the mainly design benefit to have this tier?
Yeah. So as I said, we rely on the hypervisor manager, like a vCenter or the Zenso pool, to provide us a lot of the services, right? So we don't try and go directly to the host API. We talk to the hypervisor manager. And so if you want to live migrate VMs between hosts, then they have to be in a cluster. That's what the hypervisor manager says you have to do. Did that answer your question? Yeah, okay. And the hypervisor manager says that you need to have some shared storage between these guys so that you can migrate the VMs. Because it's interesting that, go ahead.
Hey, Chiradeep. Question on where would any firewalls and all of those things be connected in this in the architecture?
Yeah, that's a good question. The question is where would we connect firewalls? So typically, and I'll come into networking later on, we support many different modes of networking, but the most popular is we use VLANs to isolate. And so as long as the firewall and the load balancer has one interface on the internet side and one interface where they can access that VLAN, so you can deploy them anywhere. But typically, yeah, right around there, hanging off the L3 core.
Okay.
Sure.
And one more question is that these hosts, do they refer to physical devices, or are they like virtual machines when you got into
These are hypervisor hosts. Sure.
Hello?
Yeah.
You have an L3 core. Is it an ordinary router? Is it correct? Cisco router, for example.
The access layer?
Sorry, L3 core.
L3 core, yeah. It's typically, yes, any of the Cisco, Juniper, whatever you want, yeah.
And
Dell, Fortinet.
is it under control of CloudStack?
No.
No. Okay.
But Not today, but there's no reason you can't. You can write a plugin which controls it. I'll come into the networking later, but today, for instance, if you have a VM running here and a VM running in this pod, so let's say a tenant has a VM in this host and a VM in this host, then he has a common VLAN which stretches across the L3 core. So that has challenges because you need to provision every VLAN on every link there. And so if we wrote a plugin which controlled the L3 core, then you could selectively enable VLANs on different links. Sure.
I can probably help you with that. We actually trunk 300 VLANs down into every server in a consistent manner using bonded network interfaces and then a dedicated management interface on the native VLAN. And then what we did is we provisioned that directly against the actual tenants themselves as individuals, spanning above layer 3 at layer 2, outside of the actual virtualized infrastructure into the physical. So by trunking all of your VLANs in, you're able to selectively activate whichever one you want across all the clusters in a zone.
There was a question here.
The availability, the zone, is it more like the availability zones in Amazon where it's geographically how should I say it? It's geographic, or is it more about per customer, kind of like in a multi-tenant?
We support both. So the original idea is that this is a multi-tenant infrastructure. So you could have multiple tenant VMs here. And then you could have multiple availability zones and use the same CloudStack management server to manage multiple of them. And so the idea is that if this zone fails, customers have a choice in deploying VMs elsewhere. But there is also the concept of private zones. So if you're a managed service provider and you have lots of hardware, and a customer says, I want to make sure that only my VMs run on any set of hardware that I'm actually multi-tenant, then the service provider can set up a private zone. So this is what it's showing here, that we can have multiple availability zones. And there's nothing saying that one zone is within one data center. So if this data center has multiple redundant power supplies, and then if you're fairly confident that zone 3 is not going to fail at the same time as zone 2, then you can deploy them in the same data center. But the entire thing is managed by a single management server cluster. And so that's showing here that the management server is in one zone, but because we assume there's like high-speed links between data centers, it can manage all the zones. And you can deploy multiple management servers for scale and reliability. They automatically cluster as you start more of them. And typically, a single management server can manage up to 5,000 hosts. So I'm sure we can tune it to be better if needed, but seems like a good goal to have. And so if you have like a single management server, it talks to a MySQL database. You typically put it behind a firewall so that admin and user APIs can access it. If you do a multiple management server cluster, you put a load balancer in front of it. So you get automatic sharding of user requests. And then each of them, the management servers talk to each other, automatically shard the physical resources underneath. They pick, if there's 3 of them, they pick 1/3 of the hosts for themselves to manage, and then they manage the hosts. And then you really want to do like slave replication just to make sure that your database is reliable. The management server, I think, you usually QA on RHEL and Ubuntu, RHEL 5.4, but we have a community using it on Ubuntu and Fedora as well. Any questions so far about the deployment of the management server? So we had a discussion earlier about primary storage. So the primary storage is shared storage for a cluster, so that primarily so that you can boot quickly, and then you can also do snapshots and migrate VMs between hosts. And then we allow you to specify a storage network so that the hypervisors have speedy access to the storage server. And then depending on the hypervisor, there's various technologies supported. If typically all hypervisors support iSCSI, Fiber Channel, and NAS. And then you don't have to limit it to one. You can have multiple volumes, multiple primary storages. And then you can also tag these. Let's say you have 3 primary storages. One of them is SSDs, one of them is 10K drives, and one of them is regular 72 RPM drives. So then you can tier the storage, and then we saw the disk offerings earlier on. And then when the user wants to create a VM, he can say, I want the SSD offering, and then we'll go off and create it on the SSD primary storage. And of course, you as a provider or you can charge more for that. Sure.
So I had a question kind of going back to the hypervisor.
Yeah.
CloudStack 3.01 came out, and Zen Server 6.02 is out, but the Zen pack doesn't match up, and so you're still using Zen Server 6.0, and with limited support for 6.02, which has a number of bug fixes. Is there a roadmap where these releases are going to be in line so that when the updated version of Zen Server and security packs come out, we're not behind from a security perspective?
Let me see if somebody else can answer this. Yeah, that is the goal. As it happens today, that the Zen Server team has a separate release schedule, and the CloudStack has a separate release schedule. But we are moving some of our test cases into Zen Server automated test cases, so that they cannot release without CloudStack also working on the latest release. But I don't know when that's actually going to happen, so well, that's the goal. Sure.
Hello. Can I confirm that restriction of that zone? When we use 2 zones and they have each secondary storage, is it correct? And if we try to access the secondary storage in another zone, is it prohibited? Is it correct?
The way you access the way you access secondary storage is typically you're trying to get access to your snapshots or your templates. Mm-hmm. So we do provide a way to copy mm-hmm. your templates from one zone to another.
Uh-huh. Okay, thank you.
Of course, everything is metered, and so you can bill for these usages. Yeah, so secondary storage, is zone level. Today it's zone level. I think a lot of people would like it to be at a management server level, so that it's shared as you were asking. So today the main use case today is NFS. So So you configure one or more NFS servers, and then use that for storing snapshots and templates. So just a reiteration: host, storage, cluster, pod. A network is end user network, secondary storage, and then the management server farm. So what that animation just showed was, let's say you're an end user and you said that I have my special template. It's a, let's say, a Windows template which you have customized. What you do is you upload it to a file share, and then you tell CloudStack about it. CloudStack management server will download it through a service VM and install it on secondary storage. And when it's ready, it'll tell you it's ready. And then once it's ready and you want to run a VM with it, what CloudStack does is that it takes the template or image from secondary storage, copies it to primary storage, and then boots a VM off of it. And then primary storage actually can also be local storage of the host. So fairly standard way of doing it in the IaaS clouds. And you can even import ISOs. So very useful for installing Windows if you don't have a license to begin with. So just reiterating, so the end user requests an instance. We have something called a deployment planner, which can be customized. So we pick a host to run the VM on. We tell the host that, okay, we need to configure the network for that VM. We copy the instance template from the secondary storage to primary storage. And if that template is already there on that particular primary storage, of course, we don't bother to do the copy. Create the data volume on the primary storage. And creating the data volume on the primary storage is usually a clone operation, right? So you can do fast cloning or thin provisioning. Create the instance on the host, plug the volume into the VM, and then start the instance. Any questions about the VM start process? Okay. So I'm just going to go into a little bit of how each hypervisor works. There's some differences, obviously, because each hypervisor has its own special way of doing things. If you look at Zen Server, there is no central master for Zen Server. You install them in a pool, and then they elect a pool master, and then the pool master coordinates all the actions of the entire Zen Server cluster. And so when CloudStack talks to the Zen Server pool master, it's using the native API, which is called Zappy, to talk to the Zen Server pool master. And any operations to, let's say a VM is running here, typically if you want to stop that VM, CloudStack Manager talks to the Zen Server pool master host, which then tells this slave Zen Server to stop the VM. This slide is talking about system VMs, and I'll come back to system VMs later on. The Zen Server has a soft switch built into each of the hosts, but the management tends to be there's no distributed vSwitch available in Zen Server. So if you started up a VM here and here, you would have to go in and configure each switch individually, and that's what CloudStack knows to do and does. Oracle VM? Yeah. Sure. Sorry.
So right now, the native virtual switch doesn't allow you to disable DHCP in favor of other tools that can automate DNS and other information. So right now you're tied into the virtual switch. Is this going to be fixed in a release relatively soon?
I'm not sure I understood that question. Alex?
Yeah, I think it's fixed in 3.0, where you can actually turn off the DHCP service on the DOMR.
We confirmed with architecture that the switch to turn it off doesn't work.
Okay.
We have a bug open with them, but
No, I think he's talking about a Zen server bug.
no, this
That's
is
a
the
cloud-
No,
virtual.
you're talking about the virtual router.
Virtual router, okay.
Unable to turn off the DHCP service.
Yes, because
Yeah.
we want to provide DHCP out of an Active Directory
yeah.
server that can push DNS dynamically.
Right. Yeah, then it's a bug that we should fix. I don't know the timeline for fixing it yet.
Anybody use Oracle VM here? Oh, there, excellent. So with Oracle VM, there is no Oracle VM manager we integrate with. We run a CloudStack agent on each OVM host, and then the CloudStack manager talks to the OVS agent through a custom protocol. It's just JSON underneath. But if you wanted to start a VM, there's the start VM JSON command which goes to this OVS agent and then starts up the VM. And then the limitation with OVM is that all templates must be from Oracle, and then the shared storage that we use is OCFS2. And it says that it requires a helper cluster. That's because we haven't figured out how to run the system VM on OVM. KVM also widely popular. Lots of public clouds with CloudStack deployed with KVM. Once again, we don't use the remoting for libvirt. We use an agent installed on the host, which then talks locally to libvirt to manage the VMs. Just like in Zen server, network management is done on the individual bridge basis. And then there's support for Ubuntu 10.04 and RHEL 6. Anybody using different versions of KVM? No. Any questions on KVM? I know it tends to be quite popular in our open source, in the open source community, or people try it out on KVM first. Sure.
I know that with libvirt, I couldn't find a way to remotely push a template, for instance, to upload a template. Is that a capability part of the cloud the agent that you provide?
When you say push a template, push it to secondary storage?
As in import a template into the cloud. So if you already have something that is, let's say an OVA file or an XVA file, and you want to import it.
Yeah, that's a CloudStack enhancement to that, yeah.
Right. Is that the case?
Yeah, it is. Yeah.
All right, thank you.
Yeah, these tend to be very strictly VM level operations. I think even for snapshots, we talk directly to QEMU or use the QEMU utilities to do snapshots there. For VMware vSphere, because vCenter allows you a lot of fantastic tools like migration, DRs, fault tolerance, we talk to vCenter. Don't try to bypass it. And there's a native HTTP API to vCenter that we talk to. There is a some special things we need to do do Amazon-style snapshots. On VMware, what happens is that when you ask VMware to snapshot a VM, it snapshots the VM. It doesn't. You can't tell it to snapshot a volume. So if it has 6 volumes attached, it snapshots 6 volumes. So we need to do something special to take care of that, so that you get the Amazon semantics of snapshotting individual volumes. I think in 3.0 we use the vSwitch to control networking. Shortly, I think we're contributing control of Nexus 1000V as the vSwitch for vCenter, or sorry, for vSphere.
Is that the distributed vSwitch or the standalone for host vSwitch?
It's the Cisco replacement for the DV.
No, no, not the 1000. What's already in here?
Oh, that's the standard vSwitch.
The standard vSwitch.
Yeah. So here's a summary of what works and what doesn't. You can see that support for Oracle VM, there's no snapshots and no storage over provisioning. But other ones are pretty well supported. We use the native file format for each hypervisor. Zen server likes VHD, vCenter, or VMware likes VMDK, and QCOB2 for KVM. You can also actually use RAW for KVM. Those are the supported primary storages. And I think people also ask about memory overcommit, and that's something we have never done, but should be easy to do. Anybody interested in memory overcommit at all? Or? Yeah. What about CPU overcommit? Yeah, yeah. That you can tune a little bit in CloudStack. Anybody have any opinions on what densities they're going to run on their clouds? What densities you guys are looking for? Yeah, sure.
So for us, we did a lot of math around this. And if you're on the Intel 5000 series processor, your density is limited by the bus to the memory ratio. So want to watch out for that. But in the E7 line, that bus is actually universally shared across the sockets and the cores. So you're not limited by density to memory core ratio. So what we've looked at is right now our production, our main environment is running on E7s, and we're actually looking at running for starts on 2 vCPUs with 4 gigs of memory with a 15% overcommit on CPU and memory and a density of about 64 VMs per node. And really what we're looking at is to get to use these systems for seeding for high density. But what we're really looking to do is to go to blades, to go to a smaller form factor, less VMs, same configuration, and then use larger systems like the Dell R810, which is 1 terabyte of memory, local 6 terabytes of disk with multiple 10 gig links, with 4 cores, 4 sockets, 64 cores, and then building bigger VMs and separating our offerings based off of hardware and cluster groups. And so the math is fairly easy. If you guys want to chat, I can explain how it works out.
On the 810, are you doing 1 cluster per server then?
1 cluster.
Or how many nodes, how many 810s are you putting in a cluster?
So based off of the provisioning need, well, for us we've separated our data center or our tenants into 2 spaces: a compliance space where we're running PII, PCI, and audit compliance, which has a lot of automation around visibility of logging and artifacts, plus explicit in-out access roles. And general, what we're using is we're tagging the native VLAN, and we're dynamically shifting clusters using Cobbler on the management interface to build Zen server, and then adding it into clusters as needed, and kind of jumping the fence, so to speak, so that clusters are then just commodity in the space.
Um, CloudStack, originally came from a public cloud mentality, and one of the things we built was a hierarchical administrative structure. So you have the root admin, and then which installs CloudStack and configures it to start with, and then you have domains, and domains is like a unit of isolation that typically it's like a reseller if you're a public cloud, or if it's an organizational unit like developers, QA, and then not terribly interesting to a lot of people, but you can also have unlimited subdomains, and then your accounts belong to one of these domains or subdomains, and then each account can provision multiple users. And so you as an account, you can create 50 VMs, have 10 users, and all your 10 users would have access to those 50 VMs. And then at the account level, you can impose resource limits. Typically, how many VMs can you run, how many snapshots can you take, how many IPs can you, public IPs can you allocate. I think the next topic is networking. Any questions so far about hypervisors or storage or accounts? Okay, so the Harun has come up with an answer for, well, how far behind is CloudStack from XenServer, and the intention is to be 1 to 3 months behind XenServer. But as I said, we are moving some of our test cases into XenServer automated test cases, just so that to make sure they don't break anything.
Sorry, I'm noisy. So I think we had talked with Sheng and everybody about managing the Citrix licensing out of the clusters themselves rather than going into the interfaces individually licensing, and there was talk about bundling the license inside of CloudStack. Is that going to be a path that we can expect in the near future, or are we still going to manage outside of CloudStack for visibility into the licensing portion?
Sheng, you want to answer that?
I'm not aware of any plan to address that problem in the immediate future, right? But it seems like if you have these deployments at very large scale, we should consider taking care of hypervisor upgrade and licensing eventually in CloudStack as well.
This is another view of the data center which I showed before, just showing how users come in and how the admin comes in, the pods and the secondary storage. So I'm just setting this up so that you get an idea of, well, where do the networking pieces fit in. Oh no, that's in the other slide deck. Okay. I guess a lot of you guys have used Amazon, and so you're familiar with the kind of isolation that Amazon gives you. So in Amazon, you start up 20 VMs. Your 20 VMs are not in the same subnet, right? You get different IPs, and what you use is something called security groups to make sure that each VM can talk to each other. And so that is supported out of the box in CloudStack, and that's something called basic zone. And you guys might be wondering why is it called a basic zone. I think it's just a historic reason. Traditionally, with this mode of networking, we didn't support a lot of services. And this mode of networking is a little bit easier to get up and running because you don't have to talk to your network admin to provision VLANs or beg them to add trunk VLANs into the core switch. The attraction of Amazon style networking is it's practically infinite scale. I mean, you're limited by your class C IP addresses, not by 4,000 VLANs. So what you do is you as an end user, you come in and you create some VMs. Let's say you create web VMs, and they land up on different hosts, on different pods even. Then you start up some database VMs and more web VMs. And then you can see that they're not in the same IP range because let's say this is each of them is a L3 subnet. And so your VMs are not in the same range. So then how do your web VMs then talk to your database VMs? What we do is we coordinate the hypervisor, the host-based, so the hypervisor-based firewall. That's the brick wall you see there. And let you create security groups. And so we have firewall rules in here which say that this database VMs can access each other. And then you as an end user, you can come in and say that the web VMs can access the database VMs security group on port TCP port 3306. And then everything else is dropped. We also do stuff at the firewall, like because you're sharing this host with other tenants, we also do broadcast suppression, multicast suppression, anti-spoofing, so that you have a true multi-tenant experience. Any question on L3 networking? It's also called basic zone, in case you guys have heard of that term. So we don't expect any VLANs in the core switch in this case. So just as this scales, run tens of thousands of hosts on this kind of infrastructure. It's trying to show the same thing here. It's showing, I think, let's see. You got VMs in two pods. We got different guests, red guests and blue guests. They're all getting IPs in the same subnet range. And so you could think that they will attack each other. But then we have the anti-spoofing rules and the broadcast and multicast suppression, which prevents that. And then we have also rules which let these guests access the other blue guests in there. And then with 3.0, we have a support for load balancers and elastic IPs. So you hang off a load balancer here, a NetScaler load balancer, and then you can offer load balancing to these guests, fully automated, and also elastic IP service. Anybody running a public cloud here? Oh, one. I'm guessing this is more popular with web scale workloads. People who are moving workloads off of Amazon, or people running really, really, really large data centers. The other mode of networking is called advanced zone, And that just virtualizes your physical network with VLANs. Here's an example of how that might work. You have these pods here, and then I'm showing the green tenant and the orange tenant. We start up a virtual router for each tenant. He gets an IP on the public net, which he can access the internet, and he gets an IP on the what we call the guest network as well. And so when the VM wants to talk to the internet, he uses the virtual router as the gateway. And then because the VLANs are stretched across the data center, the orange VMs can be in any pod and still access the virtual router or each other. Is that clear or not clear? Go ahead.
So in a private network scenario, this actually ends up, most private networks NAT out. They don't want to actually put public IP addresses on servers.
Sure.
And so what we've discovered is that we're actually double allocating IP space because we're not going to put a public IP on the system. Is this something that could potentially be removed? I believe we've discussed it with other teams. But however, well, for the most part, private clouds are going to want to issue a single IP address and potentially not use the virtual router as the default gateway, but control it via a physical router switch itself. And this is causing a bit of chaos because if you are constrained to a certain subnet allocation, then you're basically doubling up or even tripling up based off the routing mechanism that you're using.
Yeah, I mean, this can, I mean, you know that we support, like, this can be a Juniper SRX, right? It doesn't have to be the virtual router. And we're looking for, contributions from other networking vendors so that CloudStack can control other devices. Would that solve your problem or no? Okay, go ahead. Sure.
So what I'm asking is, in basic networking, you use the virtual router to get out. In advanced networking, you can actually use your default gateway
Sure.
as your physical routed infrastructure. What I'm talking more about is in that routed space, you've got, in your design, a router for the public network outbound, and then another route for your default inbound, and ends up that you have two IP addresses on your host. In a public cloud, this would make sense if you wanted a public IP address for every host. In a private cloud, this doesn't make sense because you're not going to expose your internal systems out to the internet using a public IP address. You can use a NAT on a firewall that's more traditional for the data center. So what happens is you actually end up issuing two RFC 1918 IP addresses to the host, and you're not using your public route anyway, but somehow it's still in there and it's causing confusion on where your least cost route goes for traffic, basically. It's kind of a bit more complicated than that. I think,
Yeah, let's discuss that later on. I'm interested in seeing why that is. But we do have the concept of network offering, so you can remove like the source NAT service. You can remove any service you don't want. Yeah, this is just one way of working with advanced networking. In this mode, the router provides L2 through L7 services, DHCP, DNS. What else? Gateway service, NAT, source NAT, firewall, port forwarding, load balancing, and VPN. Sure, go ahead. In this mode, because the VLAN stretches across the data center, if this guy sends out a multicast, it should go to all the other VMs. But are you talking about like multicast routing? No, not today. What would be the use case for that? Clustering. But that's within the VLAN, right? Yeah. No, he's asking about routing outside the VLAN. Okay, sure. Yeah, that would be supported, yeah. But in this, in the L3 case, that would not be supported. And I think I just want to clarify something that Pete said. When this web VM talks to the internet, it's through the core switch. There's no virtual router involved. It can either go through the load balancer or the L3 core switch. There's no virtual machine involved there to intercept the traffic. It does go through the host-based firewall, though. And another thing we did as a tech preview in the upcoming release is you can configure these connectivity for your tenants using software-defined networks using overlays, and that's coming out as a tech preview in the next release. What's the benefit of that? Oh, sorry, yeah. So the limitation here obviously is you have 4,000 VLANs. VLAN is 12 bits, so typically 4,000 VLANs. What happens is that sometimes your switch actually falls over even before you can provision 4,000 VLANs. And so if you use a software-defined networking, which just uses overlays, then you can go well beyond 4,000. And the scalability problem then becomes something like the L3 scalability problem, where you're controlling thousands and thousands of virtual switches from the CloudStack management server, as opposed to controlling thousands and thousands of hypervisor-based firewalls. So it's moving the scalability problem in a different way.
Question? Does CloudStack support have anything like an OpenFlow controller that is inside the manager?
Yeah, so that's what I was talking about. We have a built-in OpenFlow controller. It doesn't talk OpenFlow today to the vSwitches, but it can. Just because I think the protocol that is supported in the vSwitch doesn't let you set up tunnels today. So we use the hypervised API to do that. But you can, using the network plugin architecture, you can talk to any third-party OpenFlow controller you want.
And one more, there are a couple of different kinds of tunnels. There is STT, there's WXLAN, and so on. So what is supported with CloudStack? That
really depends on the hypervisor. So what we did for the upcoming release is works on Zen Server 6, and that supports that has OVS, Open vSwitch, built into it. And the release of Open vSwitch it has supports only GRE. It doesn't support VXLAN or STT. Yeah. Go ahead.
Hello. Yeah, my name is Thomas. I had a question about will it be possible to attach more than one IP address to one virtual machine without using advanced network? Because I don't want to use NAT.
Don't want to use NAT?
A lot of customers use more public IPs on the same VM, and I don't want to have NAT between them.
Alex, can you correct me? I believe it's supported. I saw the code to support it. But it is a popular request, yeah, because if you look at traditional VPSs where people run multiple websites with different SSL certificates, they want different IPs for that, yeah.
Yeah, I have to look back
yeah.
To our stuff too.
Yeah, I'm not sure. I'll get back to you on that.
Okay, thank you.
So here's what it looks like as a virtual network. Again, we got the blue VMs and the red tenant. Everybody gets their own virtual router VM, and that virtual router VM is doing things like NAT, DHCP, load balancing, and VPN. Now, the VPN I'm talking about here is just a remote access VPN. You got your Windows, Mac, or iPhone, and you want to connect back into your network. You can use remote access VPN to do that. And you can see that because of the VLAN isolation, they get the same IP space if needed. Actually, when you create a network, you can ask for any CIDR you want. What's not here is IPv6, as you can see. Here's some variations on this layer 2 guest networking. Here we had the CloudStack built-in virtual router providing you load balancing, NAT, etc. Or you can do physical devices. You can say, I wanted a Juniper SRX and a NetScaler load balancer. And then once you install this using the admin UI or admin API, we treat it as a multi-tenant device. And then we configure rules on the SRX or the NetScaler to give you the same service with the same API that you get with the virtual router. And then there's variations here where you can say that I want the load balancer behind the firewall as well. So it's a side-by-side versus inline one. We also support the F5 load balancer, and then you can see here for IP address management and DNS, it's still running the virtual router, but all it does is provide you DHCP and DNS. And if you do the layer 3 type of isolation, either you can run it on the public, where every guest VM gets a actual public IP address, or actually this is wrong. Or you could front it behind the NetScaler load balancer, give it private IP addresses, and then allocate public IP addresses on the NetScaler load balancer. Sorry about that. These should be RFC 1918 addresses. And then the virtual router is running in each part just to give you a DHCP and DNS. Oh, question there, sorry.
Hello.
Yeah.
So this external load balancer is supported only in advanced zone networking or even in basic?
This one here?
You have the NetScaler load balancer.
Yeah, this NetScaler is supported in both. The F5 is not supported in both. F5 will be supported only in advanced, but it should be easy to put.
So any vendor can write plugins for.
Yeah. I mean, it's all everything's written as plugins, right? So any vendor can come and write their own plugin. So what happens is that when the API request comes in, we have this well-defined set of callouts into the plugin, and as long as your plugin respects those or understands and implements those callouts, you can orchestrate anything there. Third-party SDN controllers, Cisco devices, or whatever you want to do, you can do it. It's just a matter of writing the code and testing it.
Hello? Is this a CS virtual router sitting on management server, or it's a different host machine?
It's running in the same physical infrastructure that your rest of your VMs are on. Yeah, so because the management server can be in a different zone entirely. Right? So let me show you this here. So you can see that the virtual router here is running inside a hypervisor in the cluster which supports the rest of the VMs. So one of the you could say guiding goals or design principles of CloudStack is that the management server is not in the data path at any point in time. If we need to be in the data path, we orchestrate service VMs to do that, or physical devices to do that. And if you did something like this, your vendor would provide you, HA. So if you wanted a firewall to be HA, they have a native HA for SRX. NetScaler has HA for itself, and they would just use that, and CloudStack wouldn't care whether they used HA or not. Go ahead.
I had a question on, right now we are seeing most of these are having two networks. That's one is public and one is for the internal one. Sometimes there is a storage network that's completely separate. Can that be plugged in this architecture?
Storage network into the VM?
Yeah.
No, what we do is.
I don't think he's talking about storage.
Well.
No, yeah, into the VM, yes. Storage network into the VM sometimes.
Yeah, I mean, if you look at what we let you do is, typically there's two other networks here. One is a control network to talk to the hypervisor, and then there's a storage network. And so we let you tell us what storage network the hypervisor is connected to. And when the VM is, when the hypervisor provisions or talks to the storage, it talks to the storage network. But the VM never has direct access to the storage network.
Well, so there's actually there's the network of providing the block device to the VM, and then the VM may actually want to have direct access to the storage server through a specific network. And for that, you can actually have the administrator provide a shared network that is owned only by that particular account, and that network can be plugged directly into the VM, and as long as the storage server is accessible through that network, the VM can access that. But it's an administrator functionality only.
But so that means that there is so when the VM moves, right? This network is now dangling. Somehow it has to get those IPs back into the space there. So there seems to be a third network that should be there, where when a VM moves from one to the other, two networks might be configured, but the third one from the storage that comes in, there has to be some provision through which it has to be attached.
When you say when the VM moves, do you mean VM migration?
Yeah, so let's say a hypervisor is not, went down, and then the VM moves to another hypervisor. If it is not in the CloudStack space, then that third network won't be configured on the.
Oh, no. In this case, it is in the CloudStack space. So in CloudStack, you can have the administrator. There's a huge echo with this thing. Yeah, it is. It is. So what you can do is the administrator can say, hey, I want to create a network for this account only. It's on a specific VLAN. And then when the VM is launched, the end user will pick and says, oh, here's the default network. And here I also want to be participating on this particular shared network. And when the VM is launched, it will actually come up with two NICs. One NIC is on the default network for going out on the internet and things like that. And then another NIC would be on this storage network. And when the VM moves, then actually the NICs move with it. There will be gratuitous ops to make sure the IP is moved so that it doesn't lose those IPs.
I think when we come to the networking deep dive later in the afternoon, we'll discuss that. Or I'll actually draw it out and show you how it's done. It's getting to be 11 o'clock. I got Alex coming up and doing a little more deep dive on architecture later on, but let me just quickly go through this. So you saw that you could do any number of different combinations here, and the way you do this is you do something called a network offering. And so you go to the admin UI, and then you design your network offering saying that I want a virtual router or NetScaler or F5, whatever, to support this kind of network, and then when the end user creates a network, he has a catalog of network offerings which he chooses, and if he chooses one that has a NetScaler providing load balancer, then he automatically gets a NetScaler. And then if he's happy with the virtual router to begin with, and then later on says, I've got lots of traffic, he can shut down his network and then upgrade his virtual network to the next offering, and then start up his VMs, and then he should be up and going. Although I don't think you need to shut down your VMs. I think you just need to start I don't know. You do have to shut down the VMs, yeah. For upgrading from network offerings, yeah.
It kind of depends. When for NetScaler and F5, the multi-tenancy is implemented by IP address domains versus VLAN domains. And so even though you have multiple VLANs going into them, your IP addresses have to be segmented. For the VR, we don't. So then when we upgrade from VR to NetScaler, then we do have to shut down the VMs to reprogram the IP addresses so that the VMs can actually be participating.
Hello. The virtual router is only needed in advanced networking mode, right? Not used in the basic mode, right?
In basic zone, what it does is it provides you DHCP and DNS.
Okay. So it can be used in both modes.
Yeah, you pretty much have to use it because you want the guest VM to get an IP, so you need to run DHCP somewhere, and so that's why you run it in each in basic zone as well.
I think it also provides the user data.
Yeah, so if you're familiar with Amazon's user data and metadata, then the virtual router would provide that facility for you too.
I was using the metadata here, but there was one metadata which was not publishing correctly, not sure, but that was the public host name. That was still showing the one which was provisioned through the CloudStack. So public host name is the one which has to be one which is registered in the DNS, right?
Sure, I'm sure that's a bug that can be fixed.
Okay, all right.
I mean, just to clarify, these virtual routers are started up automatically. I mean, you don't have to do anything, lift a finger to do it. The first time a VM starts in this pod, the virtual router starts up automatically. And then if it dies, we restart it. So it's all automatic, fully, autonomic, if you can use that word. And same thing with this as well. If this virtual router, you can actually deploy two in a redundant mode using VRRP, and then, or if you're happy with failover times in tens of seconds, you can just deploy one of them. If we detect that this one died, we'll restart one more and reprovision the state. You lose some connections, obviously, but the static configuration will be recreated. Go ahead.
Yeah. Hello. How is the VLAN space managed between your physical network, let's say your physical router and a virtual router?
So the virtual router doesn't actually see any VLANs because the hypervisor removes the tag and gives the network to the VMs. So the virtual router is just like any other VM.
Oh, okay. So all the tenant VMs, including the virtual router, they're going to sit on one particular.
Exactly. Yeah.
Okay.
One more question related to virtual router. Is this virtual router, say, transparent to user, or user has to specify the virtual router in the deployment?
Yeah, so when let me go back to the user experience. Sorry, all the way back. right there. So, oh boy. Okay. Yeah. So when you do a deploy VM, so you've selected your template, you selected your service offering, you selected your disk offering, and now you select the network you want to deploy the VM in, right? And if you're not happy with any of these networks, you can add a new network. I mean, and the new network wizard will say, well, which network offering do you want? And if the network offering says that all these services are provided by a virtual router, then you get a virtual router.
So for CloudStack, it's actually very important for us that we hide all the physical underlyings and only expose virtual concepts to the end user, right? So to the end user, what they are getting are networks, network rules, things like that. And then CloudStack is the one that maps to underneath. So they understand they have a network, and when they're inside the VM, they see they have IP address and can go out, but they do not understand that, oh, it was implemented by VLAN 40 or 45, things like that.
A question on just on the networking side. If you had to look at, say, there is some congestion in the network, and you've got some VMs which are going to be which require some additional quality of service, and you want to specify, say, a .1p bit or anything like that that is specific for to give a higher class of service for that. Is that possible with the virtual router or with any of the other switching or networking infrastructure that you have?
When you design a network offering, you can actually specify, I think, the maximum rate, but that's typically enforced by the hypervisor. At the virtual router, we don't try to enforce anything. Virtual router tends to be connected to the public internet slow enough. It doesn't really matter. Yeah. Go ahead.
You made a comment about IPv6 earlier.
Yeah.
Can you repeat that? And so this has been really focused on IPv4 address allocation and conservation in the world of IPv6. Hopefully, A, everything just works, and B, you don't have those problems.
IPv6 is a very confusing world. There's about 200 RFCs, trying to do the exact same thing. One RFC saying the other is bad and pointing at each other. I don't think that the networking community has arrived at IPv6 best practices. What's NAT? Is it 4 to 6 or 6 to 4 or tunneling, or what do you want to do? What we can easily support is if we do not have the virtual router, then we could just allocate IPv6 here, public IPv6 here directly. That's very easy to do. It is when you want to do, and the other thing that's easy to do is IPv6 addresses for your load balancer. It's the question of what do you want to do if there is any routing involved. Do you do BGP on that, or do you do OSPF, or how do you exchange these routes and so on and so forth? So, and we haven't. I don't think anybody is. I've certainly welcome input from the community on how to do stuff like firewalling on IPv6 and all those services on IPv6.
This is not supported today in CloudStack.
Not supported today. Yeah, but the primary confusion comes in when you want to do. You got your own IPv6 public space here. How does the rest of the internet know to come in here? Do you do do they bring their own IPs? Do they do subnetting? And then there's well-known attacks using IPv6 and ARP, which have not been solved by a lot of vendors yet. So.
That is on the roadmap, though, yes?
Yeah. Who's that? Sorry.
Here. Sorry.
Oh, yeah. Okay. Thanks.
Is that coming later? I think it's said in the fall is on your roadmap, or?
Yeah.
Okay.
Okay. Are you thinking about using DHCP for IPv6 or the router announcements?
It's probably going to be DHCP.
Okay.
Windows is well supported DHCP. I know that the later Linuxes also support DHCP. The base case seems to be router advertisements, but
Advertisements, indeed, yeah.
yeah, but
Announcements.
DHCP v6 is increasingly supported. Yeah.
Okay.
Because it's just you get more control with DHCP v6. Yeah.
No, but it is most of the Linux distributions, they don't support DHCP v6 out of the box. So you have to go into the instance, enable it before it works.
Oh, is that right? Okay. I was under the impression that it just works with the 6.0 and the 11.04. Okay. So as I said, IPv6 is a lot of people will want it, but in practice it's not there yet, at least in North America. I'm sure the Japanese have different opinions. So we have a bunch of system VMs to optimize the data path for CloudStack. Generally, they're stateless, so the die we recreate them, and then if there's any state that's associated, like firewall rules or load balancing rules, we just reprovision them from the database. And then these VMs are special because they have access to the control plane, and they can talk to the management server. Usually they have three interfaces, one to the public because they're providing a public service, one guest so that they can talk to other VMs, and a control plane so that they can talk to the hypervisor or to the management server. One example is the console proxy VM. It gives you an AJAX style HTTP console viewer, HTTPS, sorry. What it does is grabs the VNC output from the hypervisor and then allows you to view it on the browser. And then as you get more and more demands for consoles from your end users, we automatically spin up extra console proxy VMs to do this. And what's happening is that there's a Java-based server sitting inside that VM, which is performing the functions for you. Similar story on the secondary storage VM. So it's how the management server can talk to different NFS servers across different zones. So if you want to download templates, manage your snapshots, this is what the secondary storage VM does for you. Somebody asked about copying between zones, so we let you do that using this particular VM. And then if you add multiple mounts, then we will just spawn multiple secondary storage VMs for you. And last but not least, virtual router VMs provides all these wonderful services. So you can do redundancy, and typically the management server configures the virtual router SSH. And if it's Zen server or KVM, it'll talk proxy through the hypervisor. What it does is it sends a plugin command to the hypervisor, and then the hypervisor sends an SSH command to the virtual router. Just some information what it is today. It's Debian 6 squeeze, and then it tends to get revved every CloudStack release. It's 32 bits. And what we have offerings for the virtual router too. So you can ask for small or big virtual routers. So you can say I want 1 core or 2 cores or 4 cores. And we found that for maximum performance, you typically want 2 cores and 4 gigabytes of RAM. We only install essential software packages because it is like a security access point for the end users. So it's just some best practices on security and performance. Just try to get the latest versions and keep it patched to the latest security updates. Go ahead.
In our recent deployment, we found a number of problems finding documentation on your network workflows, what ports you're listening on, where's the source, origin, destination, which made it exceptionally difficult to actually build a proper security scheme from an ACL perspective outside of CloudStack. Is there any documentation or is there any future effort coming to document the workflow of ports that are going to be used?
Alex, could you take down that note for me? Certainly a valid question. I have seen a PowerPoint for somebody, but every port listed, and I can see if I can dig that up.
Yeah, I saw that in the docs. It wasn't accurate with 3.0. We basically turned on our firewalls and looked at deny routes on multiple destinations. VNC, for instance, listens on a large port pool, but then does a translation in AJAX from an HTTPS connection to a VNC connection, and then reroutes you from your host directly to the VNC port on the Zen server, not necessarily the VM on the Zen server.
Right.
As an example of something that wasn't very clearly documented.
No, it's certainly a very good concern, yeah. We should document that. Some more details about the system VM. So because we use SSH to SSH into the system VM, when you install the CloudStack management server, we generate new keys, and you can randomize the system VM password as well. And then if we have any patches to, because there's scripts and processes inside the system VM which can change, or there's bugs in them, you can actually patch them by just restarting them. They just check if there's they mount a special ISO, they check if the ISO has changed. If so, it patches and then reboots. So again, highly automated. A lot of this happens behind your back. And then the same system VM works on Zen Server, KVM, VMware, so that you can do a multi-hypervisor cloud. And you know, it's a fairly well-defined way of orchestrating your system VM. So if you wanted to do something special for yourself, you want to monitor something, you want to do some other specialized task inside the cloud on behalf of the management server, it's there and you can use it.
Are all of these completely stateless, i.e. could be run out of a Pixie boot environment as opposed to stateful on disk installed?
Today, I know somebody did a Pixie boot implementation for CloudStack, but what is supported today is just template based. So we can't do Pixie boot. Yeah. Go ahead.
Yeah, this is a question for if a pod has heterogeneous hypervisors, so probably KVM and VMware. So what are the priority rules on this for the system VMs? Where would they go in a heterogeneous pod?
Yeah, right now it's random.
Okay.
But you know, feel free to raise an enhancement. Go ahead.
So you have a you have this as a Debian-based system, and previously it was something other than Debian. How modular is it if we want to change the underlying operating system? Or how modular could it be made?
It could definitely be made more modular. There's a script which builds the system VM, and so you just run, you know, build system VM.shell, and it just goes after the APT repositories and builds it. So in that way, it is fairly easy to replicate on different operating systems because the list of packages is there. I know some operating systems call the same package differently. Like I think it's Apache 2 on Debian and versus HTTP on CentOS, I think. So there is one script which is the cloud early config, which needs to be customized. That's the one that mounts the ISO and tries to figure out, well, what is this VM? And I think if that's fixed, I think it's easy.
So I know we've had some issues around kernel versions. Is there a set of tests that we could apply towards will this function as a system VM and all of the potential roles? That especially as we start adding things like Open vSwitch type capabilities. Does that exist today? Is there a defined or even a defined list of you must have these things or these kernel modules built and enabled and loaded?
That's a good question. No, there is a lot of assumptions built in about what which router can do. I think Alex and I have discussed having like a capability set for, and then when you install your cloud, you say, well, what capability set does this template have? Certainly, that's an improvement we can do. Yes.
Okay. I'll file a bug for that.
Yeah, sure. And I think, you know, it'll be great if some other operating system comes in, Fedora or yeah. Debian does tend to be, you know, conservative in going to the latest, so that's why I like Debian. But if you guys want the latest and greatest, sure, go for it. Man, okay. Let's see. Some of the big blocks inside the CloudStack. We got the UI, obviously. You guys must have seen it. We have service management, which is through APIs, billing, metering, accounts. Set of image libraries, the templates we talked about. We give you services like backup, load balancing, you know, the entire suite of network services and monitoring. And then resource management, we can pick, you know, or customize which hypervisor or which host you want to run your VMs on. Workload management, you know, you can put hosts into maintenance, pods into maintenance. A whole bunch of fine-grained control we provide, and all over, you know, this set of hypervisors on a set of physical resources. The octopus. I think somewhat to Pete's question is like, what happens where? So you got these bunch of people coming in, the UIs, monitoring servers, people using fog or EC2 API. They're all talking the CloudStack or admin and end user API to this cluster of management servers. And between the cluster management server, there's a custom protocol maintaining the cluster state, you know, figuring out who's going to control what. The cluster talks to MySQL, right? And then depending on what hypervisor cluster they're talking to, if you're talking to Oracle, it talks Zen API, vCenter API, Zen Server, Zappy. If it's KVM, we run an agent here on each host in the cluster, and we talk our custom JSON protocol. If it's the Juniper SRX, for example, we'll talk netconf, Nitro API to the NetScaler. So it's all native APIs. There's no attempt to reinvent the wheel here. And then we have agents inside each of these system VMs, and we'll talk to them using JSON or through SSH. And then the secondary storage VM will also talk HTTP to Swift or to the file share to download and manage your templates and snapshots. The secondary storage VM also mounts the NFS server, the secondary storage, and all the hypervisors also have access to the NFS server. The console proxy VM talks VNC to all the hypervisors. It grabs the console images. And then if you're an end user, you come in through the Ajax console and view your images from the console proxy VM. Any questions on this? It's just a repetition of whatever I've been saying. Oops, here we go. So inside the CloudStack server, what happens is that you got this API servlet, standard Tomcat servlet. Did I mention that CloudStack runs inside Tomcat? It's just a web app inside Tomcat, right? You get this API servlet. It wow, what happened here? Sorry, it's a mixture between Mac PowerPoint and Windows PowerPoint. It's not looking formatted correctly. It just gets, you know, formed into commands and queued up inside this job queue. And then there's a thread pool that just takes up jobs from this job queue and calls the services API It's a well-defined interface API here, which then calls into the CloudStack kernel to do the exact task. You want to start a VM, you want to create a volume, snapshot a volume, and then the kernel reads from the database, writes to the database to do whatever it needs to do. And then it talks to this message bus over an agent API. And then the message bus makes sure that the end resource, which is like a hypervisor or a network device, which understands the API for the hypervisor or the network device, this resource gets that command from the message bus and then talks to the end resource. And then we have these plugins and adapters here which help customize the behavior for the kernel. If it's a different networking model or a different, is it basic zone, or is it advanced zone, is it a particular kind of storage which supports snapshots or not, which host to deploy on. You can customize the deployment planner. So these are all customizations which third parties can write, or there are lots of them built into into CloudStack as well. And so you get this staged, asynchronous way an API flows through the system. It gets queued up in one job queue here, and then as the kernel decides what to do with it, it sends it to one or more end resources to do its job through a message bus again. Any questions about this?
Excuse me. Job queue, is it just standard GMS queue?
Today it's just an in-memory queue, standard.
But it is
No.
GMS API.
No, it's not JMS API. It's a homegrown version. It's backed by the database.
What database?
Backed by the MySQL database underneath.
Okay.
Go ahead.
Is it possible you guys would replace this with something like ActiveMQ or RabbitMQ? That way you can make that bus more generic. We can use it for other systems to tap into those notifications.
Absolutely. I think, and part of the move to open source is hoping people can make that replacement.